In this video, we're going to be talking about rates of changes, and the way we will do that is we'll basically approach these questions with the use of chain rule. So if you have something like dy by dx, then the chain rule tells you that this will basically be equal to dy with respect to some other quantity, let's call it d triangle, multiplied, and I'm going to represent multiplication with a dot sign, multiplied with d triangle over dx. And so if you look at it as a fraction, this thing will cancel out that thing, and you will basically get dy by dx. And you see what this chain rule does is it basically relates three different quantities. So it relates it relates y, triangle, and x. And what it says is that, well, if you want to relate y with x, or in other words, dy dx, and you have this third intermediate quantity, then what you can do is you can basically first relate y with the triangle, then you can relate the triangle with x. So in other words, this would just be dy over d triangle and d triangle over dx. So basically, this thing is equal to this thing multiplied with this thing, right? And so this is the exact mindset we're going to use when we are going to be solving this question over here. It says the volume of a balloon is increasing at a constant rate of 50 centimeters per second. So what does that information even tell us? What is a rate? What is a rate? A rate is basically something that's changing with respect to something else. So if I say the gradient itself is a rate. It's a rate of how y changes with respect to x. A rate is basically a gradient. So over here, they say the volume of a balloon is increasing. So they're talking about a volume. One of the quantities is the volume of the balloon, and it's increasing at a constant rate of 50 centimeter cubed. So this guy is the volume, and it's increasing by this 50 centimeter per second. So it means they're basically relating volume with time. They're relating one quantity with respect to time. So in other words, I can just write this information down over here. I can say that, okay, dv, let's call the volume v. So I can say that dv by dt, okay, so they're relating volume with time. That's basically equal to 50. Okay, and then I can add a plus sign over here if I want to. That plus represents that it's increasing, not decreasing. If instead I added a negative over here, that basically means that the volume is decreasing with respect to time. So this is my first quantity, dv by dt. It says that my volume is changing by 50 centimeter cube per second, and you can write the units over here. So you can write centimeter cube per second if you want to. I just personally don't want to do that right now, but you can go ahead and do that if you want to. And then they ask us, find the rate of increase of radius. So what does that statement mean? That statement basically means that you have to find dr by dt, right? The rate of change of radius, the rate of increase of radius. So you have to find the dr by dt. And they say when, so they give you a condition when the radius is 10 centimeters. So what that means is that you have to find dr by dt at a certain instant, and that instant is where the radius will be equal to 10 centimeters. And then they give you this last bit of information which tells you the volume of a balloon is equal to 4 by 3 pi r cubed. So that's a formula. I'm just going to write that down over here. Volume is equal to 4 by 3 pi r cubed. And r is obviously going to be representing the radius. Right. So we need to find this guy right over here. We need to find this guy. And see, one of the hints that we already have that we need to apply the chain rule is that we're given one sort of this one rate of change, and we are supposed to find another rate of change. So we're given this dv by dt, and we're supposed to find this dr by dt. That already hints you that something may be related to chain rule. So before I even get into the mathematics of this, I will explain it to you guys what all of this means at the end of this problem. But first, we are going to apply some mathematics over here. So we have one quantity, volume, right? Let's see how many quantities we have. So we have one quantity, which is volume. One of the quantities is time. Another of the quantities is radius. And what we're supposed to do is so I need to arrange them in order, right? Like somewhat like this. I need to arrange them in some order like that. So what I can sort of understand is, I don't know what the order is right now, but what I can sort of understand is that I have to find r with respect to t, right? So I have to find r with respect to t. And what's my middle quantity? What's that other quantity they've given me? What's that other quantity they're talking about over here? Well, that's volume with respect to t. So what I can sort of tell you guys over here is that I'm supposed to find r with respect to time, but in between them I have this other quantity v that I don't really want. I want this thing with respect to that thing, and I have a middle quantity v. So how do I do that? Well, I go from over here to this middle quantity, and then I go from this guy to that guy. So what does this even mean? So that basically means that if this is dr by dt, then this is going to be dr by dv, and then this is going to be dv by dt. So basically, I know that my dr by dt is equal to this dr by dv multiplied with this dv by dt. And see, what we can sort of understand over here is how easy it was to just apply the chain rule, because all we did was we realized all of this entire question, it comes down to whether you can sort of identify these three different quantities and whether you can make a connection between them. The rest of it is just really simple mathematical stuff. See, once you've drawn this over here, once you've made this connection, everything else just comes really easy to you. So my advice will be to keep this chain rule in mind and just go practice a lot of rate of change questions and just sit down with them, try to come up with this formula over here, try to come up with this connection over here. Give the questions time, just learn how to make these connections. The rest of the question is going to be really easy, so I'm going to show you guys how we can sort of do that. So we know that dr by dt is equal to dr by dv multiplied by dv by dt. Okay, so do we have our dv by dt? Well, yes, we do have it. So that is basically this guy right over here. We do have our dv by dt. It's positive 50. So we know that this guy is just positive 50. Now, do we know what dr by dv is? No, we don't know that. We have no idea what dr by dv is. But one thing that they have given you is this equation over here, which says v is equal to 4 by 3 pi r cubed. And there's two ways that you can find dr by dv from this equation. One of the ways is to find dv by dr, and that's just basically going to be, so it's 4 by 3 pi r cubed, right? And so basically, if we apply the same differentiation over here, it's 4 by 3 pi r cubed, you can see 4 by 3 pi is going to be a constant, so we can get it out of the integral. So it's just going to be d by dr Sorry, I wasn't supposed to do that. This is going to be 4 by 3 pi, and then it's going to be d by dr. So what is this going to differentiate to? So if it's just the same as if you had this thing and you were differentiating it. So what is this going to be? This is just going to differentiate to 3x squared, right? So that's exactly what's going to happen over here. So all of this is just going to become 3r squared. So this is being multiplied with 3r squared. And then this 3 can cancel out that 3. So you will be left with 4 pi r squared. 4 pi r squared. Now see, this is not dr by dv. This is dv by dr. But one thing you can do is you can reciprocal this. So when you reciprocal this side and you reciprocal this side as well, you will get dr by dv is equal to 1 over 4 pi r squared. That's one thing you can do. Another way you can sort of use this equation to find dr by dv is, well, you make r the subject. So you make r the subject, and if we do that, well, if we have all of this, so this is going to be v equals 4 pi by 3 r cubed. So we send this entire fraction over there to the other side. It's going to reciprocal. It's going to be 3 over 4 pi v equals r cubed. And then if we send the cube over there to the other side, so it's going to be r equals cube root 3 over 4 pi v. Okay, that's going to be the cube root when we send it over there. And I know you may be like, well, this doesn't look anything like this over here. That's because you still have to differentiate it. You made r the subject. Now your next step is to differentiate r with respect to v. And then you'll basically differentiate all of this with respect to v as well. And then you'll basically, when you do all of this will solve out to give you this thing over here. So these are the two methods. Either you can do this and take the reciprocal, or you can make r the subject and then you can differentiate r with respect to v. Either way, you're going to find your dr by dv. So in our case, this dr by dv, this is just equal to 1 by 4 pi r squared. So now we sort of know that our dr by dt is going to be equal to 1 over 4 pi r squared multiplied by positive 50. And all of this is just going to give you 50 over 4 pi r squared. And see, this is the formula for dr by dt. This is what you want. And then you're like, well, how do I, this is still not my answer. I needed to find the rate of increase of the radius when the radius was 10. So now what do? Well, you already have the formula for dr by dt. They just want you to find this thing, which is the rate of the change of radius at a specific instant, and that instant is where radius is equal to 10 centimeters. So the way you do that is basically, you know, the value of r, which is 10 centimeters, you just go and you chuck that in here in place of r. And I'll actually go ahead and do that for you guys. So this is going to be 50 over 4 pi 10 squared. And so we can simplify this a little bit. So this is going to be 50 over 10 squared is 100. 100 multiplied by 4 is going to be 400 pi. And then this 0 can cancel out this 0, and it's going to be 5 times 1 is 5, and 5 times 8, I believe, is 40. So it's going to be 1 over 8 pi. And you can put this in your calculator. You can solve this out. It's going to give you the answer. But this is the rate of change of the radius at that instant where the radius is equal to 10 centimeters. Now, what does all of this even mean? We've done the math. We've done everything. What does all of this even mean? Before I tell you guys that, I'll just say the entire trick to attempting these types of questions is this chain rule right over here. And basically observing this thing, that you have one quantity, you need to find the change in that quantity with respect to another quantity, and in the middle you have an intermediate quantity. So you have to sort of connect all of those three quantities, and then you have to sort of come up with this formula. This is what you guys should try and do. All of this other stuff, all of this mathy stuff, this is easy stuff. You will figure this out. The answer lies in solving this part out. This is the difficult part. So this is what I want you guys to focus on. I want you guys to go do as many rate of change questions and just focus on this part first. So now, what does all of this even mean? So, well, let's take a balloon over here, and they tell us that the balloon is increasing with time, right? The volume of the balloon. So let's say the volume is v of this balloon. So we know that the volume of this balloon will be increasing over time. So let's say over time it just becomes a bigger balloon now. Right now it's going to be something other than v, something greater than v. Okay, so now it's going to be something greater than v, and then it's going to keep on increasing as time passes on. Now, what they're asking for is, well, if you take this as your point 1 and you take this as your point 2, then what you can sort of realize is that this balloon also may have some radius over here. And as the volume changes, the radius at point number 2 has also increased. And so let's say over here the radius is 10 centimeters. So they're basically asking for this specific point when the balloon has a radius of 10 centimeters. At this point, how is the radius increasing with time? That's what they're asking.